All right, so for 57, if we do some force diagram action, well, we've got kind of like this, the tension, right? Tension has Ty, has Tx. There must be the mass, the weight, the force of the, the beam, and then there must be the force of the worker or whatever that is. And then also, like, in this way, this is going to be force of the wall, right? The normal force of the wall pushing out to counteract Tx. So then Ty, so we know that some of the forces in the y has to be 0. So Ty has to equal the force of the beam plus the force of, I don't know, let me say P, force of the person. Okay, does that make sense? And then then I'll pick this as my pivot because technically there's also like a force up from the wall maybe. I'll just do the torques right now. And then I'll look at the torques there. So if I look at my torques accordingly, if I do my torques accordingly, then I have one torque from this going up, and then I have two torques going down. Well, sorry. I have one torque going counterclockwise and two torques going clockwise. All right, so then we proceed to the sum of the torques has to equal 0. So the torque of the torque of Y or a cable or whatever it is, let's say the torque of the tension is going to equal the torque of the beam plus the torque of the person. And the torque of the beam is going to, or the torque of the tension is going to be L times T sine theta. And then the torque of the person, the torque of the beam is going to be L over 2 times the mass of the beam times gravity. And then the person is like 2/3 L mass of the person times G. And then all the L's go away. And we're supposed to find out if this person should be worried, right? So then we get 1/2 mbg plus 2/3 mpg all over sine of theta.
You're recording, right?
I think so. All right, and now let's just do the maths. So the beam was 1450, so it's 725, so it's like 7,000. And the person is 80, 2/3 of 80 is like 57 or something. Yes, 50, 53, I think. So it's 530, so it's 7,500, so 7,500 divided by sine of this. Oh, I think that person should be worried. It's pretty freaking close. I think it's like slightly over. Actually, the person shouldn't be worried. The person should be falling.
Yeah. Why are you isolating for the tension of the rope?
Because the tension, they told me that the max tension was 1,500 newtons, 15,000 newtons. So the person should only be worried if the tension caused by their creeping out on this beam is going to approach or exceed 15,000 newtons.
So Mr. McClure?
Yeah.
So basically what just happened is that like using the length, which is radius, and then you multiply it by the force of what we're looking for?
Yeah, you look by the force of the beam, force of the person, and then this is the force of the tension, and then you just solve for T. What does this come out to be?
Yeah.
What is it? There's no answer.
No, it's just saying it's where
I
you're
was-
not.
I thought police asked for it.
Yeah, you're asking if he's calling.
Oh, I know, I'm just wondering what this,
About 1,000 something.
what's that?
1,000 something.
1,000 something?
Yeah.
Really, that's all?
Yeah.
Well, I guess I did my mental math.
It's 15,000.
Yeah, 15,300,
Oops. My bad.
right? Because MB, the mass of the beam is 1,400, right? 14, so if you take half that, 725 times gravity is 10. That's at least 7,000, well, it's like 7,000 newtons. Then the person, 2/3 of 800 newtons is gonna be around 500. So you've got like 7,500 newtons here. And then the sine of 30 is 1/2. So boom, you're very close to 15,000. And so even if you don't know that it's 15,300, you should be worried because that means like you're getting close. And then in fact, like I said, this person shouldn't be worried, he should be falling. Because at 4, he already should have broken that cable. Yeah.
Can't you solve it by finding the torque of the clockwise and counterclockwise and just compare them?
And just what?
Compare them? Like,
Oh, you mean, yeah, you could. If you plugged in 15,000 here. I mean, if you did that, you'd get this is like 7,500. And then when you fill this out, is 7,500 greater, less than, equal to, or greater than this? Yeah.
There's a normal force of the wall. Why isn't there a normal force of the person?
Normal force of the person?
I'm pushing up on the person.
Oh, there is. It's like a frame of reference issue. Like the person in the beam are a force couple, so like you can assume that unless the person breaks through the beam, that that's transferred into the tension. Good question. Other questions?
So basically, we could just easily done this like by, hey, saying it equals like 15,000, and then like by a greater than or equal
What
to.
the fudge? Sorry, hang on, Elsa. My bad. Sadly, this is all recorded. Oh, that's it. Okay. There it is.